Our second speaker and our second topic is about security. Niels Provos is a distinguished engineer at Google focused on security and privacy. Now, for context, there are only about 50 distinguished engineers inside all of Google. Now, and according to his Wikipedia page, in his spare time, he turns steel into swords. You know, and security is different than many other features. It's an opportunity for us to work with you to create the best possible security environment for you, your customers. And with GCP, we have a great opportunity to put more and more of the tools that we use to manage our security into your hands so that you can manage your security as well. So with that, I'm really delighted and honored to bring up on stage Niels Provos, distinguished engineer from Google. Niels.
Thank you for the introduction, Greg. Good morning, everybody. As Greg said, I'm a distinguished engineer at Google. I am responsible for the security and privacy engineering teams. Today, I would like to pull back the covers a little bit and share with you a glimpse on how we pervasively secure you, your data, your customers' data, and your applications when you run on top of Google's cloud platform. However, let me set the stage a little bit first. At the recent Enigma conference in San Francisco, Rob Joyce, the head of NSA's Tailored Access Operations, made the following statements on how advanced adversaries manage to break into your systems and networks. Now, I understand that most of you would like to spend your time and focus on building a great product and great new features for your customers. However, your adversaries, they focus their time and energy on finding weak spots in your systems that they can exploit. Fortunately, at Google, I lead a team of experts who build systems and processes specifically designed to thwart adversaries. We do this by anticipating them, preventing them, detecting them, disrupting them, and containing them. And we will work with you to make sure that we can meet your requirements and that you can leverage our security capabilities on top of the platform. So now I would like to give you a little bit more insight in how we think about security at Google and how we have created a secure infrastructure for ourselves. Google's security and privacy team consists of over 500 people who continuously work to protect our infrastructure and you when you're running on top of GCP. Due to our scale, we end up seeing all kinds of bad behavior across the internet: phishing emails, malware websites, network attacks. And we also see all kinds of adversaries, ranging from all levels of sophistication, not just script kiddies and cyber criminals, but also nation-state actors. Now, at Google, we are not pursuing a hard-shell perimeter model. Instead, we are really focused on pervasive defense in depth. This is similar to the immune system analogy that Urs mentioned yesterday. There are two key principles running pervasively to our approach to security, and that is trust and transparency. That means that we design for trust throughout our stack, and we build in the transparency so that you can verify for yourself. And in fact, this talk is one of our steps in giving you more transparency. Now, I'll be talking about Google's infrastructure in the first part of the talk, how we think about security there. And then the second part of the talk, I will explain how that applies to you when you run on top of GCP. In order to facilitate this discussion, we have split our stack into 8 different layers. And I'll be walking from the bottom up, starting with the hardware, to the boot process, all the way up to deployment, operations, and usage. At the hardware layer, we are fortunate enough that we operate at such a scale that we can build our own proprietary secure systems. That means that we have purpose-built hardware for computing, storage, networking, all the way through to full data centers, as you just heard Joe talk about. Our ability to design and deploy custom hardware means that we can maintain provenance and establish trust at the hardware level. Now, on top of this trusted hardware, it's important that we can also boot in a trusted way. And to accomplish that, we have employed code signing that allows us to verify the BIOS, the bootloader, and the kernel. And that means that only the intended software can run on Google's infrastructure. So now that we know that our machines have booted in a known good state, it's also important that all of our jobs communicate in an authenticated and authorized fashion. To accomplish that, we have built a cryptographic key distribution system called LOAS that allows us to establish cryptographic identities for all jobs that run on our infrastructure. We know and audit the binaries that run so we can establish trust not only at the operating system, but also for the apps that are running on it. Now, we have heard a lot about virtual machines. And one of the properties we really need there is secure isolation. At Google, we use KVM as our hypervisor technology, and we have significantly invested to harden its security. That means that our security teams have found 15 of the last 21 publicly known vulnerabilities in KVM. That means that we are the first to fix and the first to patch, but of course we also contribute our findings back to the community so that everybody can benefit from a more secure KVM technology. And we continue on working to make KVM even more secure. To get a secure operating system image on our machines, we have created a Google-curated image that we run throughout our production infrastructure. This is very similar to the recommendation from the NSA of having a secure baseline. We have also deployed a service that alerts us of vulnerabilities in third-party source code to further protect our services. Now, at the storage layer, it's really important that all access to data is individually authorized and ACLed. Before we write data to disk, we chunk it and spread it so that not all data ends up on the same server. We also encrypt data and metadata individually. And to protect these encryption keys, we have built a system called KeyStore that wraps them by encrypting them further. Our storage systems only store this wrapped key and never the original cryptographic key that would be required to decrypt the data. And that means that all access to data requires an interaction with KeyStore, which gives us logging and auditing capabilities. Similar, for data in motion, we encrypt it when it travels between systems that we control. We accomplish fine-grained control over access with our internal IAM systems, and they also give us logging and auditing capabilities. So now at this point, we are running on trusted hardware. We know that the boot process was trusted. We trust our operating system. And we also have provenance for hardware, boot, and OS. We encrypt the data, and we know that all access is authenticated and authorized. Now, to secure our applications, we're pursuing multiple layered approaches. One of them is that we have built a binary on configuration verification system. That means that for all applications, we know how they were built, we know how they were configured, and we know how they were deployed. And for each of these steps, we know who was responsible for them. To put additional security into our development process, we require that all code gets peer-reviewed. That means there's a second pair of eyes that looks at the code before it's being committed so that we can find bugs and security problems very early on. To help our teams create more secure systems, we also require a security review before anything can launch. That means that we can put security into our products right at the design phase. However, even with the best practices, you still cannot prevent all security problems. And so we have created a security scanning technology that allows us to find many of the common mistakes: cross-site scripting, mixed content, mixed pinning, more strange attacks such as Rosetta Flash. And we have also used this as an example and where we can contribute back to the community. We have made our firing range testbed open source. That is, if anybody else would like to develop their own security scanning technology, we already have a ready-made app that they can test against. So at this point, our applications are reviewed, they have been tested, we believe they don't have vulnerabilities, data is encrypted, and access is authorized. But now it's time to expose these applications to the dangerous web. And there are multiple different ways in which we secure our applications there. First of all, on the network, we protect the traffic with TLS. To prevent man-in-the-middle attacks, we have put certificate pinning into our Chrome browser so that we only trust the right certificates. We have also deployed unphishable user identity to our users with unphishable hardware second factors. And to protect against network attacks, we have built-in DDoS protection. Some of you might have heard recently about Project Shield, where we announced that we are extending this DDoS protection to news and human rights organizations, as well as election monitoring sites. Thank you. At the operations level, we have built technology that allows us to patch and monitor, do incident response, forensics, threat analysis, and threat intelligence. And this is also another example where we have contributed back to the open source by making some of our forensic tools available, such as GRR or Recall for memory analytics. Now, one of the sayings that we have is the first user who is going to be hitting your application is likely going to be an app user. So we give our developers tools to be able to do reputation checks on URLs and binaries. We have automated analysis of traffic to find botnets that might be engaging in spam. And we also leverage our global view on badness to build threat intelligence on bad actors and current attack vectors. However, to reduce the overall attack surface that we face and that our users face on the internet and that all of you face, we created Project Zero in 2014. That is a team dedicated to finding zero-day vulnerabilities in critical internet software. You may have heard about the Heartbleed bug in OpenSSL, Urs mentioned that briefly yesterday, or about Rowhammer, where just reading memory can lead to remote code execution. Most recently, we announced a widespread security vulnerability in glibc. So that means that we have a team that finds critical security problems that are very widely spread. And we get the benefit of knowing about these first so we can fix our own infrastructure, but we can also work with the rest of the community to make sure that we get the internet infrastructure fixed in general. As I mentioned in the previous slide, writing secure software is difficult. And Google has been one of the first companies to create a vulnerability rewards program where we ask researchers across the world with helping find security bugs on our products. And just last year, we paid out over $2 million to hundreds of researchers who helped us build more secure products. So now let's switch over to GCP. I've just told you, and I hope you understand a little bit better about the security capabilities that we have built for ourselves. You might wonder, that's great, but how does that apply to us and when we run on GCP? These security capabilities that I mentioned to you is what enables our Google developers to live the V3 cloud experience, the next cloud experience. It means that they can focus on building amazing products, and they do not have to be security experts. Now, we understand that many of you are on a spectrum on how you develop and manage your applications, and that all of you are going to be in different points in your journey to this next version of cloud. We understand that you may have to manage and segment your network to create trust zones, or that you need more explicit control over the firewall and the network perimeter. All of you need logging and auditing capabilities. And we are really committed to help you meet your goals wherever you are on your journey to this next version of the cloud. And to accomplish that, we are increasingly making more of these capabilities available to you, and I'll be explaining to you a little bit how that is going to look like. So I mentioned previously we had 8 layers in recognition of the need that many of you need better control over the network. We have introduced a network layer here. So I mentioned to you what it is that we do at the hardware level, what it is that we do for our boot process, and at the operating system level. You're actually benefiting of all of these mechanisms already because GCP is built on top of these. Many of you have also compliance requirements, and our infrastructure is regularly audited by external auditors for SOC 2 and 3, ISO 27001, PCI DSS 3.0, and for Google Compute Engine, Google Cloud Storage, Cloud SQL, and BigQuery, we are also covered under the HIPAA BAA. That means that you can build on top of an infrastructure foundation that is regularly audited and certified. For cloud, at the storage level, all data is already encrypted by default. To give you even greater control on how data is being stored at rest, we have made customer-supplied encryption keys available to you, and we also give you audit logging capabilities. In the future, we plan on giving you even more control with a key management system that allows you to manage your own keys, generate them, rotate them, suspend, resume them, delete them, or manage the import and export of secrets. Yesterday, you have heard about our IAM system that we have now made available to you, which gives you explicit role-based access control. And we will give you additional capabilities later on in the year. Now, at the network layer, many of you require explicit control. In fact, today, there are already many ways in which you can customize your network, such as with isolated IP groups, private IP addresses, VPNs, or inbound firewalls. We are working on extending and expanding these features, including outbound firewalls. When you run on Google App Engine, you already can benefit from the security scanning technology that I had mentioned to you earlier with the cloud security scanner. We're working on creating more scanners and on increasing the scanning capabilities so you can also use it on GCE and GKE. We also plan to give you the ability to sign your binaries so that you can verify and enforce what gets to run as part of your infrastructure. We are also thinking of giving you source code security capabilities. However, that requires that you first store your source code with us, so please check out the Google Cloud Source repositories. For protecting your developers and users, we already give you the options of using security keys, which give you this unphishable hardware second factor. Many of you at the moment may be relying on this sort of hard network parameter that I've been talking about earlier. We also plan on giving you detailed and sophisticated identity and authorization tools. That means that you can write access policy not just based on the user, but also on the machine and location. You may have heard about the Beyond Corp model yesterday. That sort of goes in that direction. When you leverage Google Scale by using, let's say, the HTTPS load balancer, you also benefit from built-in DDoS protection. To protect your SSL and TLS certificates, we have been working for years on something that is called certificate transparency, that essentially creates publicly verifiable logs that give you provenance and trust for the certificates for your own domains. For operations, you already benefit essentially from all the practices that we have for the underlying infrastructure where we regularly patch and upgrade. However, for your own projects, we are looking into giving you an integrated view that gives you an idea of the patch level and vulnerabilities for your own deployments. And we're also thinking of ways of adding some of our threat intelligence into that view. You already can benefit from audit logging and Stackdriver to give you a better idea and detailed records of what's going on with your infrastructure and your data. In the future, we plan on giving you StrongAuth. This is a hardware second factor for logging into your projects. But we're also investigating additional app use signals that we might be able to make available to you when you develop your applications, such as URL and binary reputation. So these are just some of the security capabilities that we will increasingly make available to you to access and control. You already have the option for us to manage the security on the platform if you use, for example, Google App Engine. But we also plan on giving you the ability to leverage an increasing array of security features that you can manage to your own requirements. And to be clear, our goal here is to provide you the control you need on a trusted and transparent cloud so that you do not have to become security experts, but can instead focus on innovation and creating a great business. Thank you very much.